Okay, today we're just going to look at the study guide the kids have for homework. Tomorrow their quiz, some of the language will be very similar to what's in here, and it's different than the children are familiar with at this point. So we'll go over a couple of sample questions. For the comparisons, I always tell the kids to put it in standard form. So you can see this side is in standard form, this side is not. So 8 thousandths plus 5 hundredths. It was just mixed up. The thousandths is in the thousandths place. The hundredths has to be in the hundredths place. And now I can compare them more easily. And actually, I just wrote the wrong one down. I put the 5 in the tenths place. It should be in the hundredths place. So I need my 0 there. And the 8 has to be in the thousandths place. So now I can easily see if I line up with the decimal, which is what the kids should be doing, is lining up by the decimal to see which one is larger. So if I look, I can easily see that 79 hundredths is larger. This next one, 78 tenths, looks like that, and I can see I'm comparing the exact same thing. So again, just encourage the kids to write it out in standard form. If they have them line it up, because that makes it very clear for them. These ones, where they have them drawing models, that's a little bit new. So let me show you what that should look like. They're just going to draw a very basic place value chart. This would be tenths, and then you have your decimal, and then you have your ones, your tens, your hundreds. They're showing 5 tenths, so I'm just going to draw a model of 5 in the tenth spot. 5 ones. So again, I'm just going to draw a model of 5 in the 1 spot. 5 tens. I'm going to draw a model of 5 in the 10 spot. There's no hundreds, so I won't even fill that one in. This one, it says use words, numbers, and your model to explain why each of the digits has a different value. Be sure to use 10 times as much and 1/10 in your explanation. So this is the language that they're giving them to use. They would say, maybe each of the digits is 5, but 5 tenths is, we could say, equal to 5 tenths, which is less than 1, less than a whole. 5 ones is equal to 5, or 5 wholes, and 5 tens is equal to 50. Okay, so then we want to use 10 times as much and 1/10. So 5 tenths is 1/10 of, and if I look, when I say 1/10 of, I'm going backwards one place. So 5 tenths is 1/10 of 5. And I could also say that 5 is 1/10 of 10. They also want us to say 10 times as much. So if I look at the ones place, 5, or if I multiply by 10, I'll get 50. So 50 is 10 times as much as 5. Their explanation doesn't have to read exactly word for word like mine, but they want to make sure they use the language that was given to them and explain using words and numbers, and we have the model up there. For this next one, we went over a lot in class where they talked about the shift of the digits. What they're asking them to do is put it on a place value chart. So again, you're going to draw your very basic place value chart, and they want you to plug that same number in using numbers this time. So you have the ones, tens, hundreds. This time they're going to cut it in half. So beforehand, I have 5 ones, 5 tens, and 5 tenths. And they want me to multiply it by 10 to the second power. I usually tell the kids to go over here and do it because it makes it a little easier than to put it on the chart. So 10 to the second power, I have 55, and again I'm going to make it bigger, so I'm going to move the decimal 2 spaces, and I will end up with that number, 1, 2, 3, comma. This is what I end up with. So now I want to put this on my chart. And I'm going to need a thousands column. So now I can see how those digits shifted. I can see that when I multiplied by 10, they shifted forward 2 spaces, and I can draw the arrows on the chart to even show that shift. So I want to describe the shift of the value of each digit. Rather than me write it out, I'm going to explain it for the sake of time so you're not listening to me write. What they want them to say is that each digit shifted forward 2 places. If you look, see this one, it shifted to the hundreds place and then it ended up in the thousands place. So it shifted forward 2 places. So that would be explain the shift of the digits. And then the value of each digit, it increased by 100. Okay, so you could say something like the value of each digit increases by, it's multiplied by 100. It's multiplied by 100, or it's 100 times larger. The number of zeros in the product, we have 1 0 in the product, and that 0 holds our place so that we can shift everything forward 2 places. Those are some things you want to explain. Divide the product from above, from the above problem. This is the same exact problem as the one above. You would simply do your division this time. Whoop, I'm writing this backwards. So the product, so that's my answer, and I ended up with 5,550. And now I want to divide by 10 to the third power. So I would take that number and I would move the decimal backwards 3 places. 1, 2, 3. And I will end up with 5 and 55 hundredths. That's my answer. The children should know how to do that pretty fluently. The part that is a little bit confusing is where again they talk about the shift in the digits. They're asking them to put it on this place value chart, just like I did right here, and show how it shifts. So in this case, you'll be shifting the numbers backwards. I'll show you really quick. Probably I'm noticing right now you're going to need, it looks like a sheet of scrap paper to do this. There's not a whole lot of room on this paper, so I apologize for that. So I have my tenths place, my hundredths place, my ones, tens, hundreds, and again I started off in the thousands, so I want to make sure I go to the thousands place. Then draw a line, start off with the one I started off with. So I started off with 5,550, and again that's because they said product. They wanted the answer from the above problem. And I ended up with 5 and 55 hundredths. And if I draw my arrows, I can see that everything shifts back 3 places. So I would explain that the numbers shift back 3 places using words, and the value changed. It was 1,000 times smaller. I know it's 1,000 times smaller because 10 to the third power is equal to 1,000. So I would say each of the digits is 1,000 times smaller. I know they're going to be smaller because division makes my numbers smaller. Multiplication, it's going to be 1,000 times larger because they make our numbers bigger. So for these conversion, make a list of 6 numbers that will round to 13.7 when rounded to the nearest 10. So I know that it's got to end up there. So I can think of different numbers that would round that way. I know that 13.68, because the 8 is going to boss the sky around to go larger, that would work. It would round to the nearest 10. I also know 13.71. This guy, because he's smaller than 5, can't tell him what to do. That would also round to 13.7. So you're going to continue on like that. Make a list of 6 numbers that would round to this when you round to the nearest 10. These, again, are measurement conversions. The children should be pretty familiar with these. I'll go over one of them. 3.5 kilometers is equal to how many meters? We write our basic conversion below. We said 1 kilometer is bigger, so you start with that. 1 kilometer is equal to 1,000 meters. And we want to multiply because we are going from a larger unit to a smaller unit. So we'll multiply. And if I take 3.5 and multiply by 1,000, again, it looks like you are going to need scrap paper for this. 1, 2, 3. I would end up with 3,500 meters. These are all measurement conversions that the children are fairly fluent with, so they should be good with those. Arrange the numbers in increasing order. Again, they want them to understand the idea of increasing is when numbers get small to big. And they would line them up by the decimal, put them in increasing order. Then they have to take their smallest number here, write it in word form and expanded form, round each of these numbers to the nearest tenth. This one, I'll go over this, write the equation using an exponent. If Binghamton has 1.8 meters of rain that falls annually, how much rain falls every 100 years? So we want to multiply by 100 to figure out how much rain falls every 100 years. So again, I would take this, move my decimal forward 2 spaces. I would end up with 180 meters of rain every 100 years. Then they want you to write the equation using the exponent. If I wrote my equation out here, I'm just going to convert it to something with an exponent. So 100 is equal to 10 to the second power, and again, that would equal 180 meters. And I've completed the requirements of the task. Hopefully that was a little bit helpful if you were stuck on tonight's study guide. Some of the language in their quiz tomorrow, although they've been seeing it in class frequently, they've been seeing this language in their homework sometimes, they will see it on their quiz tomorrow, so I just wanted to make sure that they were familiar with that and give you some sample questions.